I have this recurring situation that drives me absolutely crazy.
Oh, I think we all have those.
Right.
Right.
But I'll be looking for my car keys.
Yeah.
And logically, mathematically, I know they simply must be on the kitchen counter.
Because you just put them there.
I literally just put them there. But when I look, they have completely vanished.
Just gone.
Completely gone. And it turns out that exact feeling of missing inventory is what astrophysicists are experiencing right now,
Oh, absolutely.
but on a massive cosmic scale. So today we're taking a deep dive into some really fascinating sources.
Yeah, we're looking at recent astrophysics papers, stellar observation data, some cosmological models.
Basically exploring what is known as the cosmological lithium problem. Our mission today is to figure out why the universe is missing a huge chunk of its primordial lithium and what that actually means for you.
It really is the ultimate missing keys scenario.
Yeah.
And to understand why scientists are why they're scratching their heads, we have to look back to the very beginning.
The Big Bang,
Right, the Big Bang. We have this model called Big Bang nucleosynthesis.
which is our mathematical framework for how the first elements were forged.
Exactly. And it accurately predicts the amounts of hydrogen and helium in the universe. I mean, we run the numbers, we look at the stars, and everything matches up beautifully.
Okay, let's unpack this.
Yeah.
Because hydrogen and helium are exactly where we expect them to be. But lithium is the troublemaker here.
Oh, definitely. When we point our telescopes at old metal-poor population 2 stars,
Which are basically cosmic time capsules, right? Because they formed so early on.
right, they're very early stars, the observed lithium-7 in them is lower by a factor of 3 to 4 compared to what our Big Bang models predict.
3 to 4 times lower.
Yeah, the math says it should be there, but it just isn't.
But wait, if the math is bulletproof for hydrogen and helium,
Mm-hmm.
how is it missing the mark so badly for lithium?
That's the big question.
It doesn't make sense that the formulas would only fail for one specific element.
No, it doesn't.
Before we get into where it went, though, just as scientists look for smart solutions to complex problems, you can too. This podcast is sponsored by Embersilk.
Need help with AI training or automation or integration or software development?
Exactly. Or maybe you're uncovering where agents could make the most impact for your business or personal life.
Check out embersilk.com for your AI needs.
So back to our missing lithium. In our sources, there's a really bizarre clue hiding in the data that might explain things.
Oh, the planet observation.
Yeah, sun-like stars that have orbiting planets actually have dramatically less lithium than stars without planets.
What's fascinating here is the gravitational pull of those orbiting planets.
Right.
The theory is that the gravity from these planets might actually be churning up the surface of the star they orbit.
It's essentially acting like a giant cosmic blender.
That's exactly it. Over millions of years, this churning drags the lithium from the cooler surface down into the star's core.
And the interior of a star sits at a blistering 2.4 million degrees Celsius.
Yes, and at that temperature, lithium is highly fragile.
So it burns.
It just gets completely burned away and destroyed.
A planet literally churning its own sun until the lithium burns up.
Yeah.
That is incredible.
It's brilliant, but it only accounts for some of the missing lithium. To explain the massive cosmic shortfall, our sources outline 3 main scientific theories.
The first one being astrophysical.
Yes. The astrophysical solution argues that the lithium was created in the exact amounts the Big Bang predicts, but it's just hiding.
Similar to the planetary blender concept.
Right. This theory suggests that normal turbulent mixing and diffusion inside all of these stars over billions of years has naturally pulled the lithium down into their fiery interiors.
Far below the surface where our telescopes can see it.
Precisely.
Okay, so the lithium was there, but the stars ate it over time. What about the second theory?
The second theory looks at nuclear physics. This suggests that our standard models might simply be missing some rare resonance reactions.
Meaning the way atomic nuclei interacted during the Big Bang was slightly different than we originally thought.
Yeah, it proposes that during those crucial first few minutes of the universe, certain subatomic interactions destroyed lithium before it could even spread out.
So the extra lithium was never really there to begin with.
Right, the Big Bang forged the elements slightly differently than we currently calculate.
Which brings us to the third theory. And this is where the sources venture beyond the standard model of physics. We're talking exotic ideas.
Like decaying dark matter?
Right, if early dark matter particles decayed and released massive amounts of energy, that radiation could have literally blasted the newly formed lithium apart.
Or even more mind-bending, some physicists suggest the fundamental constants of the universe.
The actual underlying rules of physics.
Yeah, that they might have subtly changed over time.
Wow.
It just shows how creatively scientists are willing to think to solve this puzzle. It's easy to look at a missing element as a flaw in our models, but really it's just a reminder of how much of the universe is still waiting to be figured out.
It's a stepping stone.
Exactly. Every discrepancy we find in astronomy forces us to build better tools, ask better questions, and refine our understanding of this magnificent cosmos. It's a wonderful sign of progress.
It really is. So what does this all mean for you as you go about your day? Well, I'll leave you with this. If we know that planets act like cosmic blenders that destroy stellar lithium, could the mysterious absence of lithium in a distant, seemingly empty star actually become our ultimate tool for discovering new hidden planetary systems?
It's a fantastic thought to carry with you today.
Absolutely. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.